First hour Algebra 1. Hope everybody is doing well. These are notes for 324. Continuation of our solving when we have logarithms in our equation. So a quick little review of condensing rules that are going to come into play today. Just remember today that when you add two logarithms together, you can put that together as a multiplication. So if we're adding log of a 6 plus log of an x, we can put that together as a multiplication of 6x. If we are subtracting two logarithms, we can put that together as one single log of a division. And if we have a coefficient out front, we can move it back up into the exponent. Those will come into play today. So we need to remember really our condensing rules today, okay? All right, so in example number 1, whenever we see a log plus a log on this left-hand side, we don't want that. We want one single log on this left-hand side. So we say to ourselves, what could we do with those two logs if we are adding them? Well, the answer is we could multiply the 4 times that x minus 3 and have it equal to a log base 2 of 3x minus 7. This is where we have to get to. We have to get to where we have a log equals a log. Now we are okay to drop down our arguments and set them equal. Okay, and now we can solve from here like we normally would. 4x minus 12. Let's see here, subtract. And we end up with x equals 5. Okay, but we have to get to the point where we have a single log equal to a single log. So in example 2, in an effort here to make our videos not so long and so long to download, here I've shown the work and we can just talk our way through it together. We have on the right hand side here two logs that we are subtracting. Okay, we have a log minus a log. So what can we do on the right hand side if we are subtracting? We can put those two logs together as a fraction. So you see here x minus 1 goes to my numerator, 3 goes to my denominator. So we divide whenever we subtract. Then we are to the point now where we have a single log on the left and a single log on the right. Well, now we can drop down our arguments, set them equal, and you see here I put the 4 over top of 1 and I cross multiplied and we get an answer of x equals 13. So I'm going to do the next video or next examples like this just in order to make the video not overall as long and as hard to download, guys, okay? Actually, I'm going to talk my way through you with this next one because it is a new type. Because on number 3, we see that we do not have a logarithm on the right-hand side. So remember from yesterday, what that tells us we will have to do. Eventually, we'll have to do the hook. But to do the hook, we can't have two logarithms. So we look and we say, well, we're adding these two logarithms. So that means we would multiply 6 times x minus 1. I'm just going to write this one as 6x minus 6. And now we have the proper setup to do our hook. Our hook says, or would tell us, 5 squared equals 6x minus 6. So 25 equals 6x minus 6. Do our math real quick here. We get an answer of 31 over 6. But again, since we were missing a log on that right-hand side, we had to do the hook. Okay, why don't you pause the video, try number 4, and then I'm going to come back with it worked out. Okay, this number 4 is like problem number 1, or example number 1. So if you had problems with this, you can look back at problem number 1. But here's what we've got happening. We have logs everywhere. We have a log equals a log plus a log. We can't have these two logs on this right-hand side, so we say, hey, we're adding these two logs. So what can we do here? Well, we can just take our 5 and our 8, and since we're adding, multiply them and get a 40. Now we're ready to go. Log equals log, but log 6 on both sides. So we drop the x plus 4, drop the 40, get ourselves an equation that we can handle, get an answer of x equals 36. Okay, so again, let's go on to problems 5 and 6. Pause the video and I'll come back with the work. Okay, problem number 5. We start off with a log minus a log on the left. So we are subtracting those two logarithms. So we can create one logarithm on the left of simply a fraction, x minus 8 in my numerator. 3 comes second, so it goes in my denominator. And again, they're key. Here's our underlying lesson of the day. We have to have a log equals a log, okay? Then we can drop both arguments down. Here's my work. I put my 6 over top of my 1. I cross multiplied again. We get x equals 26. All right, you can pause now and then I'll come back with the answers to number 6. Okay, on number 6, first thing we need to notice is we do not have a log on the right. So the 4 has no log. So what's that tell me? I eventually have to do a hook. But I got to get it ready to do the hook. I got 2 logarithms on the left that I'm subtracting. So I can put those together down here as a single log of a fraction. 5x plus 3 has to go in the numerator. It came first. 3 has to go in the denominator. It came second. Now I'm ready to do the hook. 2 to the 4th equals all of that. So right here you go, 2 to the 4th equals all of that. 2 to the 4th is 16. I put it over top of 1 and I cross multiplied. And I did that wrong. So we got a mistake here. Let me see, I can't multiply. 16 times 3 is 48. So this would be 45 divided by 5. We get a final answer here of 9. Okay, so hopefully you caught that and you got an answer of 9 there. This should have been, no, I did it all wrong here again. Let me just fix it all together. 16 times 3 would have been a 48 right there. Subtracted 3 would have been 45. Divided by 5, we would have had an answer of 9. Okay, an answer of 9 there. So hope this works a little bit better. Me not working out every step in front of you might make your life a little easier. Hope everything's going okay. I'm okay on my end. Do your best, stay up with everything. Okay, talk to you later.